Semiconductor supply chains are constraining industrial growth. Semiconductor availability is increasingly shaping what industrial, energy, and transportation investments can realistically be delivered on time. Analysis from the Organization for Economic Cooperation and Development, OECD, shows that while global investment in chip manufacturing is expanding, the structure of semiconductor supply chains remains highly concentrated and exposed, particularly for the components that underpin physical infrastructure. For executives overseeing factories, grids, fleets, and transport networks, semiconductors are no longer an abstract technology input. They are becoming a gating factor that determines project timelines, commissioning schedules, and capital deployment across the real economy. Capacity expansion has not eliminated structural exposure. The OECD's analysis highlights a central disconnect. Headline announcements of new fabrication facilities do not automatically translate into resilient supply for industrial users. Semiconductor production remains concentrated across a limited number of regions, firms, and process technologies. Long construction timelines, complex qualification requirements, and upstream dependencies mean new capacity does little to relieve near and mid-term constraints. Despite rising investment, production flexibility remains limited, particularly for infrastructure-grade components that require stable, long-lived supply rather than rapid innovation cycles. For operators, this means constraints can persist even as global capacity expands. Crucially, this exposure is not confined to advanced chips used in AI or high-performance computing. Mature node semiconductors, essential to power electronics, industrial controllers, sensors, rail signaling, and vehicle systems, remain especially vulnerable. Why industrial and energy systems feel pressure. First, semiconductors sit at the intersection of multiple infrastructure priorities, now advancing simultaneously. Industrial automation, factory upgrades depend on controllers, drives, sensors built on mature node chips with long replacement cycles. Energy infrastructure, grid modernization, renewable integration, and electrification rely on power semiconductors that face persistent supply bottlenecks. Transportation systems, rail, automotive, and freight assets depend on embedded electronics that are difficult to redesign around alternative components. OECD-aligned analysis further underscores that mature node semiconductors receive less investment attention than advanced chips, even though they are deeply embedded across energy, industrial, and transportation systems. As a result, infrastructure projects are often exposed to bottlenecks that are difficult to substitute around or redesign at scale. When chip availability tightens, delays ripple outward, pushing back commissioning dates, extending downtime windows, and complicating asset replacement schedules. Even well-funded projects can stall if semiconductor availability is assumed rather than secured. Supply chain fragility is a capital sequencing issue. One of the OECD's key findings is that semiconductor supply chains are vulnerable not only to geopolitical factors, but also to upstream dependencies involving energy, water, specialized equipment, and materials. These dependencies introduce points of failure that can disrupt production even in stable markets. For 2026 planning, this translates into a sequencing challenge. Semiconductor constraints increasingly affect when capital projects can be executed, not just whether they are approved. Automation upgrades, grid investments, and fleet electrification efforts may need to be staggered as component availability becomes uneven across suppliers and regions. This shifts semiconductors from a procurement consideration into an early-stage planning input, forcing executives to align capital timelines with realistic supply conditions. Why this is not a short-term adjustment. The OECD analysis makes clear that supply resilience lags demand growth, particularly as AI deployment, electrification, and automation accelerate simultaneously. While new capacity may ease pressure over time, it does not eliminate concentration risks or shorten lead times in the near term. For industrial, energy, and transportation leaders, this means semiconductor constraints should be treated as a structural condition rather than a temporary anomaly. Planning models that assume rapid normalization risk, underestimating delays and cost escalation across multi-year asset programs. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.